Hello, this is Satbir. The topic of our discussion in this video tutorial is the chain rule of differentiation. In our previous videos, we learned how to calculate the derivative of some simple function. For example, x to the power 3, e to the power x, and trigonometric function sin x, cosine x, etc. We also learn how to calculate the derivative of the addition and subtraction of two simple functions by using the addition and subtraction rule. And we learn how to calculate the derivative of the product of two simple functions by using the product rule. And the derivative of the division of two simple functions by using the quotient rule. In this video tutorial, we will learn how to calculate the derivative of a function if one simple function is sitting inside of the another simple function. For example, here the simple function x to the power 3, this simple function has been shoved inside of the another simple function which is sin x. And in our second example, the simple function 2x square plus 7, this simple function has been shoved inside of the simple function x to the power 8, or in other word, the power function. So if one simple function is sitting inside of another simple function, these type of function are known as a composite function. To calculate the derivative of the composite functions, we use the chain rule, which is the topic of our discussion. Before I give you the formula of the chain rule, let me give you an intuitive idea how should the formula of the chain rule look like. As we know, the derivative of the function tell us what is the rate of change of the function. For example, if I change in x, the derivative of the function will tell me how fast and slow my function g will change. And we calculate that change by computing the derivative of the function g prime of x. So that will be the rate of change of g. But since this is a composite function and g is sitting inside of f, the change in g will bring the change in f. So we will calculate the derivative of f at g of x, because g of x is causing that change. So we can say that the total change in the function y when x change, it should be the change of the outer function, or in other words, the derivative of f with respect to g, because g is the function which is causing change in f, but there is a change in g which is caused by x. So the formula of the chain rule should look like this. Or in fact, this is the formula of the chain rule. The formula of the chain rule read as the derivative of the outer function, and that derivative is evaluated at the inner function, and then we will calculate the derivative of the inner function and put it outside. To have a better understanding of this rule, let's practice this rule with some example. So my first example is f of x is equal to sine x to the power 3. So first we have to identify which is the inner function and which one is the outer function. As you can see, the simple function x to the power 3 is sitting inside of the sine x. So therefore, the sine x is the outer function and the x cube is inner function. So now we can use our chain rule, so which is the derivative of this function. First we will calculate the derivative of the outer function, which is cosine of x. The derivative of the sine x is cosine x, and then we will evaluate this derivative at the inner function, which is x to the power 3. And to finish this problem, we will calculate the derivative of the inner function and put it outside. So this will be a 3x square, which is the derivative of x to the power 3. So we can write this solution a little bit more organized. 3x square cosine of x to the power 3. So the derivative of our composite function sine x to the power 3 is 3x square cosine x to the power 3. Let's take one more example. So my next example is f of x is equal to 2x to the power 3 plus 7 and then whole raised to power 2/3. First we will identify which one is the inner function and which one is the outer function here. So as you can see, 2x to the power 3 plus 7, this function is sitting inside of the power function x to the power 2/3. So I will select this function as my inner function. And once this is an inner function, so the rest of the function will be outer function. So this is my outer function. So once we have selected the inner function and outer function, we can compute the derivative of this function. So f prime of x, it will be, first we will calculate the derivative of the outer function because the outer function is a power function. So we will use the power rule. So 2/3 and I will take 1 from 2/3. This is the power rule and we evaluate this derivative at the inner function. So we will plug inner function inside 2x to the power 3 plus 7 and then we will take the derivative of the inside function and put it outside, which will be 3 times 2 6x square plus the derivative of 7, which is a constant function, so its derivative is 0. Now I will do some simplification. So if I do some simplification, this 3 will cancel this 6 and that will left 2 here. So 2 times 2 is 4 x square and this is a 2x cube plus 7 2/3 minus 1, which is basically 1/3, and I will leave my answer in this form. Next, I will show you one more method to calculate the derivative of composite function. In this method, we will use the Leibniz notation. To use that method, first you have to identify the inner function. Once you identify the inner function, you're gonna call this function with a different variable. So I select the variable u. So I will make the substitution of my inner function with u and I put that substitution back into the function and calculate the function now basically at u. So or in other words, my function, the original function will have only u in it. And then I will calculate first the derivative of the original function with respect to the variable u and I will calculate the derivative of the substitution function with respect to x and I multiply them together. To have better understanding of this rule, let's practice this rule with some examples. So my first example is the function y of x is equal to 2x to the power 3 plus sine x then whole raised to power 50. First we will identify which one is the inner function and which one is the outer function. As you can see, the simple function 3x square plus sine x, this function is sitting inside of the power function x to the power 50. So I will select this as an inner function. So once we identify which one is the inner function, I will make my substitution. So I will select my u. So u will be 2x to the power 3 plus sine x. So if this is a u and I plug that u back into my original function, my original function will become u to the power 50. Next, I will calculate the derivative of these two functions individually. So definitely I will calculate the derivative of du with respect to x because this function is depend on x. Therefore, this will be 6x square by using the power rule. and the derivative of the trigonometric function sine x is cosine of x. And the derivative of the function y I will calculate with respect to u, because the function y depends on u, and this is another power rule, which will be 50 u raised to power 49. Now I will use the chain rule to calculate the derivative of the variable y with respect to x. So according to the chain rule, the derivative of y first I will calculate with respect to u, and then u is a substitution, then I calculate that derivative with respect to x. Or in other words, I will take this function and this derivative and multiply them together. So what I will get, 50 times u to the power 49, and this is a multiply to 6x square plus cosine of x. But I have one more thing to do, because this derivative is now depends on two variables. But I want to calculate the derivative which only depend on x, because it is given that my function was only in x variable and u was the variable which I selected. So I will plug back the value of u in my derivative. So if I do that, it will be 50, and u is this function 2x to the power 3 plus sine x, and it is power 49, and then I will just multiply 6x square plus cosine of x. So this complete the derivative of the function 2x to the power 3 plus sine x and whole raised to power 50. Next, I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Next, we will calculate the derivative of one more challenging problem. As you can see, the function h of x is a composite function. So we will first identify which one is the inner function and which one is the outer function. So as you can see, this function 5 plus 7 f of x, this function is sitting inside of the square root function. So we will basically select this function as a inner function. So if this is an inner function, I will use the Leibniz formula to calculate the derivative. So I'm gonna make my u substitution as 5 plus 7 f of x, and then my h of u, because h will now depend on u, will be u square root of u, or in other word u to the power 1/2. Now I will calculate the derivative of these functions individually. So du with respect to x, the derivative of 5 is 0 because it is a constant function, and the derivative of 7 times f of x, since f of x is not given, so I will just write down the notation of this, the derivative of the function. And now I will calculate the derivative of the function h with respect to u, because this function is now depend on u. So the derivative of this function will be u to the power negative 1/2. So therefore the derivative of the composite function h of x with respect to x, it will be the multiplication of the derivative of dh with respect to u times du with respect to x, or in other words 1/2 u to the power 1/2, and then whole thing is multiply 7f prime of x. Again, I want to have my answer only in x variable, so I will substitute the value of u back into this derivative. Therefore, the derivative of the function h prime of x is equal to 1/2 5 plus 7 f of x whole raised to power 1/2, and it is times 7 times prime of x. Since we wanted to calculate the value of the derivative at 4, so wherever I see x, I will plug 4. Now since the value of the function f at 4 and it is a derivative at 4 is given, so I will plug those values and then simplify. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.